Hello everyone and welcome to this lecture on role-based access control in Kubernetes. So introduction to role-based access control. So role-based access control, shortened as RBAC, is a way of regulating access to a computer or network resources based on the roles of individual users within an organization. It allows you to dynamically manage authorization efficiently. Kubernetes uses something in this particular like rbac.authorization.k8s.io API group. So this is an API group rbac.authorization.k8s.io and this API group is used to drive authorization decisions, allowing for dynamic policy configuration. So it looks like this. When you start the Kube API server, there is the authorization mode, so it can have any number of authorization mode, but for RBAC this keyword is specific RBAC, and when you start the Kube API server, by default it will be RBAC, and then you have got some other option, but the important key takeaway is authorization mode. So if you go and check out the Kube API server.yaml, this RBAC would be one of the option in the authorization mode. So this is a very high level overview. So you have got users who get assigned to role or cluster role. So I'll be talking more about role and cluster role in subsequent slides, and based on the role and cluster role that they have access and that they have got, this has got permissions, and there's something called role bindings and cluster role bindings, and then they get access to the resources. This is the high level RBAC architecture in Kubernetes. So understanding RBAC API objects. The RBAC API declares 4 types of Kubernetes object, and those are role, cluster role, role binding, and cluster role binding. These objects can be managed with tools like kubectl, like any other object, or you can define them through YAML manifest YAML files as well. It's essential to note that these objects impose access restrictions, and the misconfiguration may lead to restrictions preventing some changes, especially for learners experimenting with a cluster. So this is if you are new to cluster, so this is just some word of caution. And this can be managed, as I mentioned, through kubectl or through YAML file. You can do a kubectl apply, or you can do kubectl create all those 4 objects. So role and cluster role in RBAC. Role and cluster role are objects that contain rules signifying a set of permissions. Roles are always specific to a namespace, while cluster role is a non-namespaced resource. So just remember this. This is a non-namespaced, so it's cluster wide, impacting the whole cluster. Cluster roles offer flexibility in defining permissions on namespaced resources for individual or all namespaces and on cluster scoped resources. So cluster role can be are flexible, and they can be used for namespace, all namespace, or cluster scoped. So some resources are clusters specific, some resources are no namespace specific. So it can manage, cluster role can manage all these 3 types of resources. So this is some key difference. So role, namespace specific, only grants access within the specified namespace. Cluster role, cluster wide, grants access to all namespaces in the cluster. Resources can grant permissions for any namespaced resources. Can grant permissions for any namespaced resources in all namespaces or a single namespace when binding with role binding and non-namespaced resources. Usage, ideal for granting access to resources within a single namespace. Ideal for granting access to resources cluster wide and for creating roles that will be reused in multiple namespaces. Binding, binds with role binding. Cluster role binds with either role binding for a single namespace access or cluster role binding for cluster wide access. So some differences between role binding and cluster role binding. Again, namespace specific, binds to a role to a set of subjects within the specified namespace only. So role binding binds to a subject. So I'll just talk about what are those subjects. Cluster role binding, it's cluster wide, binds to a role to a set of subjects across entire cluster. Role reference, so role binding can reference both role and cluster role. When a cluster role is referenced, the permissions are applied only within the role binding's namespace. For cluster role binding, can only reference a cluster role. The permissions defined in the cluster role apply across the entire cluster. And usage, ideal for granting access to resources within a single namespace to a specific set of objects. And these are users, groups, or service accounts. Ideal for granting cluster-wide access to a specific set of subjects also used when you want the same set of permissions to be applied across multiple namespaces. So we have role, which is namespace specific, and cluster role, cluster wide, and they both contains permissions. Cluster role, so it can have namespace resource 1 permission over some other namespace, or namespace or cluster scope resource. So this is how it looks like. You have API version, kind, metadata, namespace. So that's why we have got namespace, because it's role. For cluster role, this will not be there or may be there, depends. So you can either omit or not omit. And then it has got names, and then there are rules. Basically, these are permissions. So this one is saying, so this is core group. So if otherwise there is some API groups. So it depends, like for deployment or some other object, this will be, but for the core objects, it will be just put empty space and resources pods. So this one is saying that this rule permission allows to get, watch, and list pods, and this will be the name of the role. And this is how the cluster role looks like. So namespace omitted, since cluster roles are not namespaced. So that's why. So just I want to correct. So in this role we need a namespace, but for cluster role it's not required, or it should be omitted, since they are not namespaced. So we just have name, and then we have got rules. So similar thing for core group. At the HTTP level, the name of the resource for accessing secret. So object is secret. So this one is saying you can get, watch, and list secrets, and the name will be secret reader cluster role. Understanding role binding and cluster role binding. Role binding and cluster role binding grant the permissions defined in a role to a user or set of users. A role binding operates within a specific namespace, while a cluster role binding is applicable cluster wide. They can both reference a cluster role, thus allowing the permission defined to be applied within a specific namespace or throughout the cluster. Once a binding is created, the role or cluster role that it refers to cannot be changed. To modify the role ref, the binding must be removed and a replacement must be created. This restriction ensures the full list of the subjects in the binding is intended to be granted the new role. So you have role binding, cluster role binding, and this is a typical. So role binding grants role, and it contains permissions which gets assigned to the user. Same cluster role grants cluster role, and then permissions. Important thing is like role binding. So this role binding can reference a role and cluster role. So this is the key important thing to remember. Role binding can have a role reference. So there is a role ref field. So it can have a role object or a cluster role object, but for the cluster role binding object, it cannot reference role. So just cluster role binding cannot refer a role, but of course it can have reference to a cluster role. This is what the anyway typical use case. And binding refers to role, cluster role. And so if you want to, if there is a role binding or cluster role binding, you cannot directly update the role or cluster role. So you have to remove the binding. You cannot change. In this case, like I want to, the point is this role and cluster role. Let's say a role binding or cluster role binding has got a role or cluster role. You cannot directly update and apply the object, role binding object. You have to remove the binding. You have to delete the role binding or cluster role binding object, and then create new binding if you want to assign or reference to a new role or cluster role. So this is how it looks like. You have API version and you have kind. In this case, it's a role binding, and it has got name, read pods. You can specify the namespace, which namespace it exists. So in this case, it's default. And then you have subjects. So you can specify more than one subject. So in this case, this is an array. So subjects. So you have this dash, and you have kind, user. So it can be user, group, or service accounts. So name of the user, and API group. Then role reference. So this is how a role binding takes a user and a role, and it creates a link between user has got access to this role, and there will be a role. So this must be role or cluster role, because it's a role binding. If it's cluster role binding, it will be only cluster role. So this, in this case, it will be one of the values, role or cluster role, because role binding. If it was cluster role binding, this will be kind will be only cluster role. And it's saying this user has access has assigned this particular role pod reader. So this must match the name of the role or cluster role you wish to bind to. So this must be created beforehand, and name is case sensitive. Okay. And this is how this user Jane gets assigned this particular role. Now this is one more example. This role binding allows Dave to read secrets in the development namespace. You need to already have a cluster role named secret reader. So this is again role binding, and then read secrets. Namespace is development. The namespace of the role binding determines where the permissions are granted. This only grants permissions within the development namespace. And then you have subjects so you have a Dave user, and role references cluster role in this case. So in the previous we have seen a role pod reader, but in this case we are saying a cluster role, and this is secret reader. But this secret reader role is sorry, this whole thing will be applicable only in development namespace. That's what namespace determines where the permissions are granted. Okay, next one is cluster role binding example. So kind is cluster role binding, so that's why kind, it can only have cluster role value, it cannot have role. So this one is this is a group, so there is a manager group. So this cluster role binding allows anyone in the manager group to read secrets in any namespace. So that's why we don't have any namespace, and anybody who belongs to manager group can read secrets in any namespace. And this is a role secret reader. So this has so this role is created in such a way that anybody in manager group can read secrets in any namespace. So this is how group is attached to a role ref. Okay, resources and sub resources in Kubernetes RBAC. Kubernetes API uses string representations of object names such as pods for pod to represent and access resources. Sub resources are represented similarly, for example, logs for pods logs. So the URL for an API endpoint follows the structure. So I'll showcase that. For an API endpoint follows the structures. So it's something like /API /v1 /namespaces namespace pods name log, where pods is the resource and log is the sub resource. So here so this one is about sub resources, which is log, and this is pods is a resource. So sub resources are represented similarly. For example, in this case, to read logs for a pods, the URL will look something like this: namespace and pods, and the name of the pod, or it can be wildcard and the log. Okay, an RBAC role can be written to grant access to both a resource and its sub resource. So you can have granular RBAC roles or cluster role, wherein you can have pods and a log like sub resource. It can be written to grant access to both resource and its sub resource. An example is, for example, pods and logs. So I'll just show you how it looks like, which allows to read pods and their logs. So this is the URL structure. So we have API v1 namespace pods and logs. So basically Kubernetes API, this represents logs and has sub resource logs. So resources, pods and pods log, you can create an RBAC role which can grant pods and inside their logs to have access. So this is the example. So this is a role, and it's in default namespace. It has got its name, pod and pod logs reader, and you have API groups. This one is core, and you have resources. So this is high level resource, and this is called as sub resource because log is under pods, and you can say get and list pods as well as their logs. Okay, resource name restriction and wildcards in Kubernetes RBAC. In some cases, access can be restricted to individual instances of a resource. For example, a role can be written to only allow updating or getting a config map named my config map using resource names. So this will I'll show you. So basically you can have like, for example, a resource config map, and you can go specific to a specific name of that config map or a secret or a deployment. And wildcards can be used to refer to all resources API groups and verbs. An example can be like resources can be a star asterisk and verbs can be asterisk. So resources are something like pods, deployment, secrets, config map, and verbs are basically your action. So you can have star and star, asterisk, so which allows access to all resources and all actions. However, using wildcards can result in overly permissive access and should be used with caution. So adhering to principle of least privilege. So I'll showcase these two examples. So resource name, my config map. So you can create a role which can be very, very granular. And same, you can have wildcards to basically have all resources and all actions. So this will, if you create like this, basically it's like you can do everything, all resources and all actions. So this is a role which is a config map updater, and this is in core API group. So you are saying resources config maps, and you are so at the HTTP level, the name of the resource for accessing config map. So basically this is how for the resources name should be configured. This resource has to be referenced, is config maps, and you can go this is what very granular. So you can pinpoint and you can exactly specify which config map it should update or get. So you don't have to stay at just at resources level. You can go exactly at the individual resource names level. And this is another example wherein role, it's in the default namespace, and example com super user. But do not use this in real world. So let's say if you just do API groups blank like core group, and you can just say star, basically it's a super user. So understanding cluster roles aggregation in Kubernetes. So an aggregated cluster role in Kubernetes is a single cluster role that is a combination of multiple cluster roles. This process is handled by a controller that is part of the cluster control plane, which constantly checks for cluster roles with an aggregation rule set. This rule specifies a label selector used by the controller to identify other cluster roles that should be included in this aggregation. And it is important to be aware that the control plane will overwrite any values manually entered into the rules field of an aggregate cluster role. Changes to rules should therefore be made in the cluster roles chosen by the aggregation rule to avoid unexpected modification. So this is, we are getting into a bit advanced concept. So cluster roles aggregation. So basically you have multiple cluster role, and then you can create an aggregated cluster role which can have all other cluster roles referenced, and the controller aggregates cluster roles based on the aggregation rule of the aggregated cluster role. So there will be a aggregation rule to take into consideration all the cluster role. So exploring an example of aggregated cluster roles. So in this example, I'll show in our example, a new cluster role named monitoring is created with the set aggregation rule. This rule uses a label selector to match other cluster roles that should be combined into this one. And by creating another cluster role that matches the label selector of an existing aggregated cluster role, new rules are aggregated into the aggregated cluster role. And this will be illustrated in our example, where the creation of monitoring endpoints trigger the addition of new rules into monitoring cluster role. So this is one of the cluster role, and it has monitoring, name is monitoring, and this has some aggregation rules. So we have cluster roles selectors. So basically dynamically adding the cluster roles to this particular cluster role based on the label selectors. So it's saying rbac.example.com/aggregate to monitoring true, and their rules. So this control plane automatically fills in the rules. So this is basically saying all the roles in this which has this labels setup. So, and this another cluster role, it has got labels RBAC example.com aggregate to monitoring. So this is how this monitoring cluster role, because there is a match labels, and this label is matching to the label which is specified at this cluster role, this monitoring endpoints become a part of monitoring cluster role, and this will have its own like rules. So when you create the monitoring endpoints cluster role, the rules below will be added to the monitoring cluster role. So this will become part of monitoring the parent of whichever has the match labels cluster role, and this is having some resources, services, endpoints, endpoint slices and pods, get, list, watch on all these three resources. Okay, default user facing roles and cluster role aggregation. Cluster role aggregation can be used to extend the default roles in Kubernetes. This is particularly useful for including rules for custom resources, such as those served by custom resource definitions or aggregated API servers. For instance, creating custom roles for cron tab management allows the admin and edit roles to manage cron tab resources, while the view role is restricted to read-only access. So I'll just showcase that. So aggregated cluster role extends the default cluster role and includes rules for custom resources. So aggregated cluster role, it can include, it can extend default cluster role. It can include custom resource definition. So this will come useful when you have custom resources. So you have the default resources like pods, deployment, secrets, config maps, but you can have your own custom resources through CRDs, and it can include aggregated cluster role can also include some aggregated API. So I'm just covering this so that you are aware of about all these features, but this is a bit advanced. So this is a cluster role, and this is name is aggregate cron tabs edit, and it has got some labels. Aggregate to admin and aggregate to edit true, and it has its own rules, like which API group, which resources. So this is a custom resource CRD, and basically is saying get, list, watch, create, update, patch on this particular resource. And then there is one more cluster role, and this is aggregate cron tabs view, and add these permissions to the view default role, add this permission to the admin and edit default roles. So these are the labels, and here it's these are the resources, get, list, watch on cron tabs. Okay, so now we'll just see some role and cluster role rules examples. So rules for reading pods resources in the core API group, and the second rule permits reading and writing for deployments in the apps API group. So this is established by setting the resources to deployments, and the verbs are get, list, watch, create, update, patch, delete. So I'll just showcase. So this is the first example. So this is for API groups, pods. So that's why, so at the HTTP level, the name, so this is just pod is pods, and it's saying get, list, watch on the pod. So this is one of the example of role. So basically role and cluster rules example, so this one is for roles, and it can be used for cluster role as well, these rules. So for deployment, it should be apps, and it's saying get, list, watch, create, update, patch, and delete for the deployments. Now some examples for extended role and cluster rules example. So first example which I will be coming next is a rule can be defined to allow reading / writing jobs in the batch API group. This rule lists job as the resource and include get, list, watch, create, update, patch, delete as the verbs. And second example will be a rule that permits reading a specific config map in the core API group, which can be created. And it is important to note that this rule needs to be bound with a role binding to limit access to a single config map in a single namespace. So this is first example, rules, API groups. So this is for pods. So we are saying get, list, watch, and second one is for batch, because this resource jobs is in the batch API groups, and this is saying get, list, watch, create, update, patch, delete for the jobs resources. And third one is API groups, and this is for config maps, and this is for the my config map, and just saying get. Okay, cluster scope role and non-resource endpoints access. A role can allow the reading of the resources nodes in the core group. So now we'll check some example for the node. So reading of the node's resources, and since a node is a cluster scope, this must be in the cluster role bound with the cluster role binding to be effective. So this is just an important point to remember. So if you have some rule which is about nodes, and nodes are cluster scope, they are not namespace scoped. So you must have a cluster role and cluster role binding for that to work. You can create a rule that allows get and post request to the non-resource endpoint. For example, the endpoint may be health Z and all subpaths. Okay, like the nodes rule, this must also be in a cluster role bound with a cluster role binding to be effective. So we'll see two examples for the cluster role and cluster role binding, and the second example is about endpoint. For example, if we have a non-resource, so this is non-resource because this endpoint is health Z, for example, and these are not namespace. So that's why we have to have the cluster role and cluster role binding. So this is the first one. For this to work, we have to have a cluster role. So this rule must go in a cluster role, and then finally it have a cluster role binding for this to work because it's in nodes level. Second one is so this is something new. Just this is non-resource URLs. So they are not they are cluster specific. They are not specific to any namespace, and these are the URLs. So we are saying health Z and health Z under that, and verbs is get and post. So you can do HTTP get or post to these two, and this must be part of a cluster role. This cannot be part of a regular role or just the role, because they are cluster specific. Okay, referring to subjects in role binding and cluster role binding. A role binding or cluster role binding in Kubernetes links a role to subjects. These subjects can take on the role assigned, enabling them to perform certain actions as allowed by the rule. The subjects can be groups, users, or service accounts. It is the responsibility of the cluster administrator to configure the authentication modules to produce the usernames in the desired format. So the username what you have specified, for example, for a role binding or a cluster role binding, so they can refer to three types of subjects, as I mentioned: users, groups, and service accounts. But specific to users, because these users come from some other third party, like some authentication modules. The usernames what you have that has come in as an input must match with the role binding and the cluster role binding. Okay, username and group representation in Kubernetes RBAC. In Kubernetes, usernames can be represented in various formats. So it can have some plain names like Alice. It can have email, for example, bob@gmail.com or bob@example.com. Or it can have some user IDs, for example, employee ID or some numeric user IDs. And there is a cautionary rule against using usernames that start with system. So if you are using system : as this prefix is reserved for Kubernetes system use, so just don't use system : Okay, group information is provided by the Kubernetes authenticator modules. So again, authenticator modules provide username and group names, and these groups are represented as strings with no specific format requirements. But again, however, the prefix system : just remember system : is reserved and should be avoided for group names also. So other than system : for user and groups, rest all is fine. Usernames can be just a simple name, Bob, Alice, or it can be email, it can be user IDs, it can be numeric IDs. So this is how it looks like. So you have subjects. This will go into either a role binding or a cluster role binding, and the kind is user, and you can have a user, and this user must match which come from authenticator modules. And same for a group, you can have some names defined. This is again role binding, cluster role binding. Okay, understanding service accounts in role binding and cluster role binding. Role binding examples can illustrate, for example, how roles are associated with different subject types such as user, groups, and service accounts. These examples provide how role binding works in different contexts. And API servers in Kubernetes create a set of default cluster role and cluster role binding objects. So by default, API servers in Kubernetes create some set of default role bindings, cluster role binding and cluster roles, and most of these have prefix system colon. So this is what I was talking about, indicating that they are directly managed by the cluster control plane. So system colon is a reserved prefix, and care must be taken when modifying these resources to avoid disrupting the cluster functionality. So this is how it looks like for the default service account in the kube system namespace. So it looks something like this: subjects client service account default kube system. And for all service accounts in the QA namespace, so you can have kind equal to group system colon service account slash QA. And for all service accounts in any namespace, you can have kind equal to group system colon service accounts. And if it's some namespace, it service account slash QA. If no all namespace, any namespace, just system service accounts. For all authenticated users, there is a group called group system authenticated. So all authenticated users fall into this group, and for all unauthenticated users, that will fall into system unauthenticated. So this is the example of all the default which will be set. So for kube system, there is a default service account. This is how it's referenced already in the config. And same for all users. This is the last. Okay, so kind equal to group system authenticated, and group will be system unauthenticated. This is the default value that it may get, and that's all. Thanks for watching.